Hi, this is the first lesson on the chapter on thermal properties of matter. So in this lesson, I'm going to teach on some of the basic terms that are used in this chapter. So first of all, for the contents. So the first thing that you will encounter in this chapter is the definition of internal energy. So I'll be explaining on this, which is followed by what's the difference between heat capacity and specific heat capacity, as well as what's the difference between latent heat and specific latent heat. So first of all, what is internal energy? Internal energy is actually the sum of the kinetic energy and the potential energy of the body. That means that it's the sum of two components. One is kinetic and the other one is potential. But this kinetic and potential is not the same energy that you learn in energy work power. Okay, it is specific to the molecules of the body. So let's dive into the first thing. What is kinetic energy? Kinetic energy is the energy possessed due to the movement of the molecules. Okay, it is related to the temperature of the body. And what happens is that if you have an increase in kinetic energy, it will cause an increase in temperature, and vice versa. That means if you have a decrease in kinetic energy, there will also be a decrease in temperature. So the idea of temperature and kinetic energy, it is very linked. So next, what is potential energy? Potential energy, on the other hand, is the energy that is possessed due to intermolecular bonds. Okay, so it is related to the change of states of the matter. For example, when solid change to liquid, during the process of melting, there is a change in the bonds. So when there's a change in the bonds, there will be a change in the potential energy. So when will the potential energy increase? What happens is that the potential energy increases when the bonds are broken or weakened. Okay, and it decreases when the bonds are formed. So in summary, we can say that internal energy is of the substance is divided into two main categories. One is the internal kinetic energy, the other one is the internal potential energy. Now under the kinetic energy portion, the kinetic energy is purely due to the movement of the particles, while under the potential, it is due to the interatomic or intermolecular forces of attraction. Now, under the movement of particles, it is related to temperature, while under the idea of bonds, it is related to a change of state. Okay, and then finally, this temperature relationship is tied down to the next part that I'm going to explain, which is heat capacity, while that of the internal energy for potential energy is tied down to latent heat. Okay, so let's move on to these two, heat capacity and latent heat. So we learn about internal energy being kinetic and potential. So what is the deal about heat capacity and latent heat? So let's just look at the brief definition of these two. The first thing is heat capacity. Heat capacity is the amount of thermal energy required to raise the temperature of a substance by 1 Kelvin or 1 degree Celsius. Bear in mind that 1 Kelvin and 1 degree Celsius has the same value or same difference. Okay? And the formula is Q is equal to capital C delta theta. Q refers to a symbol for thermal energy. Basically, it's just a symbol of energy. Alright? And capital C is the heat capacity of the substance. Delta theta refers to the change in temperature. So it can be final temperature minus initial temperature. Just simply this, but expressed as this symbol. Alright? Now, for specific heat capacity, it is the amount of thermal energy required to raise the temperature of 1 kilogram of a substance by 1 Kelvin or 1 degree Celsius. So if you look at these two, the only difference is that for specific heat capacity, it is very specific to just 1 kg. While for heat capacity, it could be 1 kg, 2 kg, 10 kg. It depends on the substance that is under consideration. Alright. So for the specific heat capacity formula is Q is equal to mc delta theta. The difference between these two formulas is that the C is small c for specific heat capacity, while the C is big C for heat capacity. The delta theta will be the same. Now, the reason why there's an M here is because for specific heat capacity, you need to specify the mass of the substance. While for heat capacity, the mass of substance is part of this symbol big C. Alright, so this is the difference between these two. So as I mentioned, the difference between heat capacity and specific heat capacity is that, as the word implies, for specific heat capacity, it is more specific to just 1 kilogram of the substance. Okay, it is unique for each substance. Like it is something like density. Like if you talk about density, okay, whether it is in Singapore, in Paris, in New York, you're going to have the same density for water. Water have a density of 1000 kg per meter cube. So in the same way, if you are talking about specific heat capacity of water, alright, you're going to have the same value regardless of where you specify it, whether it's in Singapore, Paris, or New York. So it is a very unique property. Once you tell me this value, I can apply to the same water in another part of the world. Okay. And then on the other hand, heat capacity of a substance depends on the mass of the substance in question. So you could have two containers of water of different size. They will have different heat capacity. Okay. So we will do a little bit of check for understanding. With this, I would like you to pause the video and to try to tell me, okay, between these two bodies of water, one 2 kg, one 5 kg, which one will have a higher or lower heat capacity, and which one will have a higher and lower or same specific heat capacity. Okay, you may want to pause the video now. Okay, so have you done? So basically, as we have learned just now, heat capacity is dependent on the mass of the object or the substance in question. So if you have more mass, you will definitely have more heat capacity if you are talking about the same substance. So in other words, for the first row, okay, definitely the 2 kg will have a lower heat capacity, while the 5 kg will have a higher heat capacity. Okay, simply because the 5 kg has more mass. Now, what about specific heat capacity? Now, as I mentioned previously, the specific heat capacity is specific to just 1 kilogram of the substance. So if 1 kilogram of water here and 1 kilogram of water here is the same substance, you don't expect it to have different specific heat capacity. So in other words, they will be the same, because I'm not concerned about how much mass are there in this container and how much mass are there in this container. I'm just concerned about, although there's 2 kg of water here, each 1 kg, okay, what is the heat capacity? 1 kg, what is the heat capacity? So if you just divide it into its smallest division, which is 1 kg and 1 kg here, they will definitely have the same heat capacity, specific heat capacity. Okay. So just to summarize what I just said, they have the same specific heat capacity because each kg of both container requires the same amount of energy to increase by 1 Kelvin. Okay, they have different heat capacity because the 5 kg water has more mass and requires more energy to increase by 1 Kelvin. Okay. So I want you to try this now. Equal amount of energy is added to a 3 kg of substance X and 5 kg of substance Y. X increases by 6 degrees, while Y increases by 4 degrees. Which substance has higher heat capacity and which substance has higher specific heat capacity? You may want to pause the video now and try it on your own first. Okay, I hope that you have finished. So for the first answer, heat capacity, very simple. You must remember what I say. Heat capacity is merely who increase less temperature. That means the one that increase the least can store the most heat. Alright? Because substance X and Y has been supplied with the same amount of energy. Now Y increases lesser, that means it is storing more energy, requiring more energy to raise by the same 1 Kelvin. Alright, so that means that the answer is Y has a higher heat capacity as its temperature rises lesser for the same amount of energy, heat energy added. Okay, so simple. Now for the second part on specific heat capacity, you can use this kind of reasoning to explain, but it's very complicated. The easiest way to answer specific heat capacity question is to use mathematical calculation methods. Now we know that the formula for specific heat capacity is mc delta theta. So what I propose you to do is to write down the formula. We know that Q represents the heat energy supply. So if it is for substance X, it will be mx Cx delta theta X, where X represents the change in temperature, specific capacity, and mass of X. Okay. On the other hand, for Y is also the same formula, but in terms is denoted as Y. So what happens is that if you sub all the values that were given to you, the mass is 3 kg, the change in temperature is 16, you realize that the amount of energy supply is 18 Cx for substance X and 20 Cy for substance Y. Now the next thing you need to do is to express Cx in terms of Q. Okay, we do not know what's the value of Q, but it's okay because these two values are the same. Then you realize that Cx is 0.0556 Q, while Cy is 0.05 Q. Now, which one is larger? Obviously, X is larger. So the answer is X has a higher specific heat capacity than Y. Now, why do I need you to use calculation method to do? The reason is because to reason out which one has a higher temperature is extremely complicated. Okay, which I will not go into detail. There is a lot of differences when you talk about per kg or per 1 degree Celsius increase. So in this way of doing, you avoid all this complex reasoning. Alright, so always remember, if you are talking about heat capacity, it's very direct, very easy to explain. But for specific heat capacity, you need to use max as the safest way of finding the answer. Okay. Now, the last thing I want to go into is latent heat and specific latent heat. Okay, so what's the difference between the two? As we have seen just now on heat capacity and specific heat capacity, the idea is also the same. Alright, so latent heat is the amount of thermal energy required to change the state of a substance without a change in temperature. Alright, LF, the formula is Q equal to LF, where F is fusion is melting and freezing, while LV is vaporization, which is boiling and condensation. Alright, so what is the difference with specific latent heat is that specific latent heat is the amount of thermal energy required to change the state of 1 kg of a substance without a change in temperature. So the difference is the 1 kg. Alright, for heat, latent heat can be at any size of the mass of the substance, but for specific latent heat, it has to be 1 kg of the substance. So the formula becomes Q equal to mLF and or Q equal to mLV. Apologies, this should be small l. Okay, so mLF and mLV. So next, what is the difference between the two? As we mentioned just now, latent heat, specific latent heat as it applies is more specific to just 1 kg of a substance. It is unique for each substance. Okay, just like density, just a specific heat capacity, specific latent heat is very unique to that substance. If I tell you the specific latent heat of vaporization for water, it will be the same value in Singapore as in Paris or in New York, because it's just 1 kg of the substance that is under consideration. Now for latent heat of the substance, on the other hand, it depends on the mass that is in question. That means if you have more mass, it will be more energy required. All right. So let's try the same lesson, the same thing again. In this case, using 2 kg of ice and 5 kg of ice, I want you to compare the latent heat of fusion between the two substances, which one is higher, which one is lower, and also the specific latent heat of fusion. Okay, you may pause the video and write down now. Okay, so I expect that it shouldn't be a problem for you to solve this one. Is using the same idea as specific heat capacity. So obviously, if you have a lower mass, you will have a lower heat capacity. Latent heat. While if you have a higher mass, you will have a higher latent heat. All right. Similarly, specific latent heat of fusion is the same, because we are only looking at 1 kg of ice here and 1 kg of ice here. Okay, I don't care about how big the mass. I'm asking per kg how much energy is required, right? So again, let's just summarize. They have the same specific latent heat of fusion because each kg of both containers requires the same amount of energy to melt. While they have different heat capacity because 5 kg has more mass and requires more energy to melt. Okay, so we have come to the end of the video. I hope that this lesson has been interesting, and do tune in to the next parts where we will delve into we will dive into the parts on how to calculate the using the specific heat capacity and latent heat. Okay, thank you and have a nice day.